Hello, hello. Can everyone hear me? All right, perfect. Welcome to Slurped. Master the art of slurping yummy data. If that doesn't make sense to you, don't worry. I'll explain what it means in the next slide. So one query. So one query is all you need to populate your front-end data. That's what I'm claiming to present to you today. So for all you front-end developers out there who have done any state management, you would notice that this is a very difficult task because you oftentimes, if you want to query data from Ethereum, you have to query it multiple times, and oftentimes there's latency, there's delays. You don't know when your data is going to arrive. And I'm here telling you, you actually can query any kind of data, any kind of structure, however long, in one query. So a little bit about me. I'm a developer relations at Mantle.xyz, a new layer 2. Those are my GitHub, Twitter, and website if you guys want to check it out. So the number one thing for a dApp, does anyone know what it is? It's the front end. That's the thing that the users interact with. That's the thing that your user sees. You know, no one really cares about the back end as long as the front end is clean and sparkling. That's all it matters from a user's perspective. And from the co-creator of React.js, you know, Albert Einstein once said, you know, front-end bugs are like the bane of my existence. So today I'm going to tell you how to avoid all those problems. We'll take a very simple case study of the Uniswap front end, where you, as everyone here I'm assuming is familiar, you would swap some tokens. To swap some tokens, you would input X amount of tokens in, and you might get X amount of tokens out. But behind the scenes, it's actually quite convoluted. There's a lot of data querying going on behind the scenes. How many ETH am I inputting in? What kind of asset am I trying to trade from? What kind of asset am I trying to trade to? How much of the asset am I going to receive? What are the balances of the assets that I have? And what are the price impacts? How much slippage will I incur? And then would I have enough ETH, or would I have enough of the asset for the button to appear? So all these are crucial information that you have to extrapolate before you can kind of create this clean UI. So a very simple approach on how you would do that is actually query them individually. You would call, let's say I would get the user's address, and after I get the user's address, I can get the user's balance. After I get the user's balance, I can query the DAI balance or USDC balance, and then only afterwards can I query how much DAI they will receive given how much ETH they're willing to put in. So this is a very simple approach. This is a very ineffective approach. It blocks, each query is blocking because you're awaiting it. One of the more naive ways to make this quicker is to wrap it in a promise, where you would call .await promise.all, and you would get everything in parallel. Now the problem with this is that you're still using 3 queries, but you're querying them in parallel. I'm here telling you that you can get everything down to 1 query, regardless of the complexity of your queries. 1 query is all you need. So can we do this in 1 query? Well, yes, we can with multi-call 3. So multi-call 3 is actually it was originally started by the folks at MakerDAO. It was named multi-call 1, then multi-call 2, and then some other Twitter guy, which I forgot the name of, extended it and made it into multi-call 3, which is now deployed on, I think, 100+ chains, all on the same address. So if you would like to use multi-call 3, it is very, very handy because they're all deployed on deterministic addresses. The essence of multi-call 3 is that it is a smart contract. Behind the scenes, normally if you query some kind of data, if your user would like to use your dApp, your user would talk to the dApp, and then your dApp would kind of query the blockchain, for example, the balance of its DAI, or the amount you would get from Uniswap, or the balance of its ETH. So each time you query it, that's one separate query. With multi-call 3, you actually call the multi-call smart contract on the blockchain, which then does the querying for you. Now, because the state of the multi-call contract is located in the same location as all your contracts, you can actually just do 1 query to the multi-call contract, and you would receive all your data. So this is an example of how you would do it with multi-call 3. You would first, the issue with multi-call 3 is that there's a lot of encoding and decoding if you're using unsupported libraries such as ethers to encode your data. So it's quite convoluted. You have to first encode it in the right structure, and then once you get the data from multi-call 3, you have to decode it out. Now, luckily, Vim, I don't know if anyone from here knows what Vim is. It's a new JavaScript library from Paradigm. It actually supports multi-3 encoding and decoding out of the box. So right off the bat, if you would like to use multi-call 3, you can actually use Vim from, I think, Paradigm to parallelize all your queries. Sorry, not to parallelize, but to make your parallel queries into one query. Now, multi-call 3 is good, but it's not good enough. The issue with multi-call 3 is that it doesn't support dependent data. And what I mean by dependent data is that it doesn't support the situation where your inputs to the query is dependent on a previous query. So for example, in this, I'm getting a vault address for some kind of yield optimizer, and then I want to query the vault address, the balance of my balance in the vault. So I first need to get the address out from some registry and then put that address into the second query. So this is the concept of dependent data. Multi-call 3 doesn't support that. However, I'm here telling you that you can actually achieve that with ETH call and a little bit of Solidity magic. So if everyone here, so people who are not familiar with the ETH call RPC call, it's actually very simple. So it's actually a JSON RPC call that you use to query the Ethereum blockchain. So on the front end, you might call, like, if you're used to some JavaScript library, you might call die.balanceoff. But in the back end, what's actually happening is that it's calling the provider, and it's using the ETH call JSON RPC to extract the data from the blockchain. Now, traditionally, ETH call is used on read-only functions. So, for example, balanceoff or decimals or owner. So traditionally, that's what it's used for. But a little known fact is that you can actually use ETH call to query mutable functions. So one example of this is how the Uniswap quota actually does this. The Uniswap quota by default is actually a mutable function, meaning that if you called it from its standard notation, it would change state, and you would actually have to use gas to call it to retrieve some data. But you can actually use the ETH call functionality to get some data from the quota, and that's how the Uniswap peripherals operate. So that's cool. So we can read and write functions. So what? What's so cool about that? Okay, hear me out. What if we hijack Solidity, made it return data in the constructor, and write the data extraction logic in the constructor? Then we use ETH call to perform a read-only contract deployment to extract our data. I'll just let you think about that for a second. So what if we hijack Solidity? What if we hijack Solidity, made it return data in the constructor, and wrote the data extraction logic in the constructor? We then use the ETH call to perform a read-only contract deployment, to extract the data that we want. Okay, I hope I haven't confused anyone here, but just to recap what the dog said, first, we force the constructor to return values. By default, constructor in Solidity doesn't support returning values. We write out the business logic in the constructor, and then we use ETH call to, quote, deploy a contract. But this deployment is read-only, and you don't actually deploy the contract. You're just deploying it so that it extracts the data, and you deploy the contract so that it performs your business logic to organize and transform your data, which you then can extract. So how do we make a constructor that returns these values? To do that, we actually need to write a little bit of assembly magic. So in traditional, in this constructor, okay, my cursor is not appearing. We first have to create some kind of ABI, sorry, we first have the ABI encode it and then do some kind of assembly magic to return the data, because traditionally Solidity doesn't support returning data. I'm just gonna gloss through this. So once we have a constructor that returns the values, we can write our business logic in between to extract the data. We can then use if call to deploy the contract. It's not really a deployment because it's a read-only function. And once we deploy the contract, we actually have the data that we need. And that is how you can query anything you need from the blockchain in one query, regardless of the complexity of your data set, of your query. So you don't have to do parallel queries. If you want to query ENS, you want to query multiple ENSs, you can do it in one query. I know there's an aggregator online. If you want to perform some kind of convoluted dependent query, data-dependent query, you can also write it in Solidity, use the if call operator to force it to return some values, and you can have everything in one go. That way your front end doesn't have to manage the complexity of dealing with updating certain kind of data sets. For example, if the price updates, what's my health factor? If do I have enough balance in my wallet? You can just do this in one query very cleanly. Some parting remarks is that you should read the if call docs because it's actually really powerful. There's an additional parameter there which allows you to overwrite the state. So what I mean by that is then you might not even need, so this state overriding is only supported on certain RPC providers. It's not supported on all RPC providers. So you could overwrite, for example, if you would like to do some kind of analysis, some kind of searching, and you're too cheap to deploy a contract, you can overwrite the contract code on this particular call. It doesn't actually override it on chain, but it will override it for that particular call. You can also override account balances or even storage slots if you know what you're doing. Additionally, for anyone who runs their own node, GAF has a GraphQL interface. Just thought I'd point it out. It's very, very handy. And yeah, thanks for listening to me ramble about querying. If you guys have any, and there's a POC. It's on my GitHub, github.com/libevm/ifcallabuser. So if you would like to check out the POC on how you can retrieve data in one query, please do check that out. Apart from that, I'm open to any questions. Thank you.
Sorry. There is time for one question if you want, so if anybody wants to ask.
If any, is there a size limit or how much logic can we actually fit in there?
So it's the contract size limit. I'm not sure how big it is, but
Plenty.
Sorry?
Plenty of space then.
Plenty of space, yeah. Awesome, thank you.